Hello, Dr. Toddy. This is Edward, and this is my Project Phase 3 video. And before we begin to the actual Phase 3 steps that I did, I want to give you update, a follow-up on your feedback in Phase 2 video. So I fixed it, as you can see. Instead of the CSV file, I changed it to Excel file. I did have to do a pip install for Open Excel in Anaconda. So as you can see, the file name is actually the original name, and it is in Excel file form. And yep, and also I fixed the here. Instead of total hit, I changed it to total punches according to your feedback. So yep, and it's still as you can see, the correlation for winning boxes is positive, and for losing boxes is negative. So that hasn't changed. But yeah, here's my little follow up for you. Now let's get into Phase 3. So for Phase 3, the first thing we did is put our datas into their natural grouping, or the natural cluster groups. So what we did is that we first select all the numeric variables for clustering, and as you can see here, we excluded all the categorical variables, and then we imported standard scaler for scaling data and clustering. We imported k-means, and then try to in order to find the best k value, and we use the ALPA method for the k value. And as we can see here, the dramatic drop happens when k equals 2. Therefore, we concluded that our k value for this is 2, and then we used it for the clusters. And as we can see, we printed out the crosstabs, and we can see here that here it is. So a big finding, based on the two cluster groups and how their characteristics are, we concluded that cluster 0, which is the first cluster group, is boxes that represent hit and move, or we can call like stick and move style boxing. So which means that the boxer, they will throw a single punch or a short combination and immediately use their feet, which is why, as we can see, their bounce time is much higher than the second cluster group, because they use their feet a lot. There are boxers that use their movement. Sometimes they're called movers as well. Like, they use their movement, they use their feet to create angles, to create and using the angles to create openings for them to initiate their attack or re-attack. So that's the first cluster group. And the second cluster group is cluster 1, and we can see that this one is the characteristic is more straightforward. As you can see, the total hit, total punches, and then their effort rating and their fatigue rating are all higher than the first cluster group, which is an indication of a pressure style boxers. They use their high volume and high activity to pressure and overwhelm their opponents, and which is why, with higher punching output, it is natural that these boxers, they exert more energy, more effort. And when I say effort, I don't mean that like I don't mean it that because this style of boxers they exert more effort. I'm not saying like the other style boxers they don't put in effort. It's just that speaking from a strictly physical aspect, the pressure style boxing will cause more physical fatigue. And another thing that confirms that the first cluster group represents um, movement based and kind of stick and move, like I said, type style boxers is that their total guard drop time is also longer because usually these type of boxers they are because if they use their feet, they're kind of naturally become like a counterpuncher. They initiate their attack from long range, which is and from long range, you don't have to put your hands up. You don't have to put your guard up because you are out of the punching range unless you explode off your back foot and then getting range, then you punch. But since they start at long range, they usually they lower their guard a little bit to conserve more energy. And like I said, yeah, they start from long range and they wait for the right moment to use their feet to push off and explode into a punching range, and then um, throw their combination or their single shot and then get out of the range. Um, but that's I want to explain why another characteristic that really represents why this is a the first cluster group represents a um, movement based stick and move counterpuncher type boxers. And another characteristics the reason I'm spending more time for the first cluster group is because really compared to the second cluster group, which represents a pressure style boxers, the stick and move type boxers, their characteristic is not as straightforward. So I want to spend just a little bit more time explaining on this. Um, the movers, they also spend more time in the clinch position, as we can see, more than the second cluster group, which is pressure boxers, because usually when the stick and move style boxing is done properly, correctly, it will kind of naturally draw their opponent to want to rush in because the stick and move boxer they keep at long range and then they find the right moment, explode in, get their punches in, get their points, and then get out, leaving their opponent frustrated. So they want to like rush in with barrages, and that's when a clinch can be used to deal with it because once you clinched up, the referee will maybe give you like 3 to 5 seconds to work, and then they will separate you, say break or stop, and get you guys back to range, and then from there, they start from long range again. So, anyways, I spent a little bit more time explaining this. So that's sorry, and a very important finding for the clustering model for the clustering models, yes, is that right here. As we can see, the bout result for loss and win for both cluster groups are identical, which means that no matter what style the boxers, no matter what style of boxing the boxers decide to use, or the activity level or effort level, they're not the only determining factors for the outcome of the bouts. Um, and it really doesn't matter like what style the boxer choose, but really how good and effectively the boxers use that style, which makes sense, really makes sense, for based on my experience, because our coaches always say like it's not about what your opponents do, it's about what you do. So it is kind of like saying like be good at what you are good at. Use Don't care about what your opponent doing. Make sure that you are good at the style that you are using so that you can, no matter how good your opponent is at um, at the style they use, make sure that you are better than them at your style. So it's a very interesting finding. And with that being said, let's move on to the regression models. So for the regression model, we chose fatigue rating as the numeric target value, and we came up with this question for this step: do boxers fatigue come more from throwing punches or more from like footwork and movement? And we selected the relevant variable for this question, which is punching output, is total punches, and footwork movement is, bounce time. The target is fatigue rating. So first we split the data, and then we scaled the variables, and then we imported all the regression models and the evaluation metrics. So we have linear regression, ridge, and lasso. And we ran all the regression models. And then we printed a result. So here we can see the R score I'll come back to this later. The R score, as we can see, is not too high at all. About 12%, the highest about 12%. So it's from R squared score, sorry. From 6% to 12%, right? And which means that only around 12% of the boxer's fatigue come from total punches and bounce time, from punching output and footwork movement. So yes, they do contribute a meaningful percentage to the boxer fatigue level, but neither of them is a sole determinant, which kind of made me realize that I talked about this in my technical document as well. I had an assumption, and really this assumption is based on my own personal experience as an amateur boxer, that I really assumed that most boxers' fatigue will come from punching output or excuse me, and footwork and movement. But as we can see, it's not. So which gave me a new perspective to the question. Beyond the punching output and movement intensity, we should look deeper into other potential sources of the boxer's fatigue, and that can be psychological aspects. It can also be a very huge factor because, and this kind of relates to like neuroscience and all that, but when you are nervous, you're literally putting stress on your nerves, and that gets you tired out really quickly as well. Like adrenaline, that's another thing. It could be your pre-match food, diet, how well you rehydrate, maybe even how well you slept, how well the boxer slept the night before the matches. So many, how they warmed up, everything. What I'm saying is there are definitely, based on this result, based on the R square value, the score, the highest being 12%, it's not that high, made me realize I need to look deeper into other potential sources for of the boxer's fatigue. And then lastly, we'll move on to classification models. For this step, we chose a categorical variable as target value to run 3 classification models. We chose bout result as the target variable. And the question we came up with this step is, are we able to predict the bout result for a boxer based on his or her offense, defense, and movement statistics. And so for this one, we chose all the numeric variables for this question, and we encoded the categorical target value, a target variable, and we split the data, scale data, kind of similar process as the regression model steps. And then we imported all the classification models, logistic regression, decision tree, and random forest, and also imported the valuation metrics. We ran all three of them, and we printed a result right here. As we can see, logistic regression has an overall accuracy of 81%, same, identical really for decision trees overall accuracy, and random forest has the highest accuracy of 94%. So what does the result mean? And this method of modeling is much more successful than the regression, because as we can see here, they all have considerably good predictive power. As we can see, they're all above 80%, 81%, 81%, and 94%. And which one is the best is, without a doubt, random forest. It has overall 94%, and from the confusion matrix, we can see that it predicted all. So 0, being the first, the one at the top being the cases of losses, and the one at the bottom being the cases of wins. The confusion matrix of random forest shows that for all 9 cases of losses, it all predicted correctly, and for 7 cases of wins, it predicted 6 out of 7 correctly. So definitely a very successful model, the most successful out of all classification models. And since it has a high percentage of overall accuracy, we are able to conclude that we are able to answer this question, whether. Sorry, let me go back to the question. Are we able to predict the BIA result for boxes based on their offense, defense, and movement statistics? And the answer is yes, because as we can see, all the models here have a very high percentage of accuracy, and again, random forest has 94, so the answer is yes. This model is very successful and can definitely be able to answer this question. So that's what I did for phase 3. Then we kind of move on to the final summary. I guess, and again, the main objective of this project was to explore and model the performance of the data of 26 amateur boxers for all 3 rounds, in order to uncover insights about the key winning factors in amateur boxing, which not only we discovered in this phase 3, we also had some pro findings in phase 2. For example, this one, the first round being extremely important, and the balance between this one right here, the balance between offense and defense is very important. And from the clusters, we learned that, right here, we learned that is about being good at what you are good at, dominate the style, dominate the match with your style. Don't worry about the opponents. Be you, do you, and you're more likely to win. And then our final conclusion is that we're able to achieve our objective for this project. And this project demonstrated how we can use analytical models to transform boxing performance data into meaningful insights that will benefit the boxers, coaches, and I talked about, like, in even for business aspect, strictly business aspect, like sports betting, because even though this model is amateur boxers data, sorry, this data set is amateur boxers data. Um, the same thing, we can definitely use this uh, for professional boxing as well, which you know is more of a business than amateur boxing. So like sports betting, sports analytics, can definitely utilize this. And with that being said, this is what I did for phase 3, and I'd like to thank you, Dr. Toddy, for being so understanding and um, giving good feedbacks. And thank you for the semester. I really definitely learned a lot, and I enjoyed um, my project a lot, and I enjoy talking about it. As you can see, I kind of went over. I don't know if there's time limit, but I kind of went over time, I'm guessing. Sorry the video is so long, but thank you again, and have a good day.